Hello, good morning, class. How are you? How was your break? So, I'm going to take you mathematics in this virtual lecture, which is powered by Exponential Computers. Now, my name is Abba Umar Jaid. Our topic for today is logarithm. Logarithm. This is our topic for today. Some have been taught in their previous classes about what is algorithm, the logarithm. This logarithm you are talking about is a vital aspect in mathematics, which is very important to use when finding solutions or problems using logarithm table. You know what is logarithm table? Huh? So now we are using calculators instead of logarithm table to find this solution, unlike logarithm table. We are using calculators also. Before you go further, let us look into this introduction. This similar introduction. As you have seen here, the use of calculators family use instead of logarithm tables. We are using calculators to do some calculations under this logarithm. However, the theory of logarithm is important. There are several scientific and engineering laws that involve the use of logarithm. When you talk about this logarithm, instead of to use that popular table to find answers, you can use calculators in a simple way. Just when you take your calculator, you see log button, just press it. For instance, when you have to do, you are given a problem like to say log of 3, you can just press your calculator. Log of 3, it will give you the answer. The same as you check under this popular table. You know what is popular table? Okay. So if a number, let us go deep into this introduction. If a number y can be written in the form of a to the power of x, then the index x is called the logarithm of y to base of a. That is, if y is equal to a to the power of x, then that x is equal to log y base a. Our base here is what? A. Our logarithm there is what? Y. Thus, since 1000 is equal to 10 to the power of 3, 10 to the power of 3, the digit there is what? At 3. You are going to start the counting from what? 0, 0, 0, 0. We have how many digits? You have how many zeros here? Therefore, 3 is equal to log 1000 base 10. Our base there is what? 10. So under this logarithm, we have 3 laws which may be applied to any base. Number 1, to multiply two numbers. When you say multiply two numbers, like to say log a times b or log 2 times 3, it will give you what? Log a plus log b. From multiplication to what? To addition. The following may be checked using your calculator. Instead of to use that popular table, you should use calculator. Log 10, it will give you 1. Also log 5 plus log 2, it will give you, when you press log 5, it will give you 0.69897 dash plus. Then you put your plus here. Log 2, it will give you 0.0, well, I mean 0.301029 dash. Then you should add them. When you add them, it will give you 1. You see, you divide our 10 here. Our 10 here is log 5 plus log 2. It will give you 1, which is the same thing as this. When you press this with your calculator, it will give you this. This log 2, it will give you this. But In a short form, when you press the calculator log 10, it will give you 1. When you go there in your figure table log 5, it will give you this, but all are the same. They are all the same. Hence, log 5 times 2 is equal to 10, which is the same thing as log 5 plus log 2. Then, second rule, to divide two numbers. When you say divide two numbers, for instance, we have log a all over b, which is the same thing as log a minus log b. This is another law of logarithm. From division toward subtraction. The following may be checked using calculators. Ln of 5 all over 2, it will give you ln 2.5, which is equal to 0.91629. Just write it using calculator, it will give you the same answer. Also, ln 5 minus 2, 5 minus ln 2, it will give you this, the same as number 1, rule number 1. When you go there using Propaganda table, it will give you this answer. And when you go there ln 2, it will give you this. Just you should add them. When you add them, it will give you this answer, 0.91629. Is that clear? Are you following? So hence ln 5 over 2 is equal to ln 5 minus 2. Is that clear? Then the third law, to raise a number to a power. When you say to raise number to a power, means like to have 8 to the power of n, or 2 to the power of 2, or 3 to the power of 3, or 3 to the power of 4, minus n log a. The following may be checked using calculator. Also, this one you can use calculator to check. Log 5 square, log 5 to the power of 2, which is the same thing as what? Log 25. Log 5 to the power of 2, the same thing as log 25. Which, when you press the calculator, it will give you this 1.39794. Also 2 log 5, it will give you this. Because you press log 5, it will give you this, then times 2, this 2, it will give you this 1.39794. Hence, log 5 square, 5 to the power of 2, is the same thing as 2 log 5. Is that clear? So, I think from here we are going to move into logarithm of number greater than 1. We have logarithm greater than 1 and logarithm less than 1. When you say logarithm greater than 1, as you see here, base 10, logarithm of a number if the power to which 10 is raised to give that number. Example, you see some examples here under this logarithm greater than 1. When you say logarithm greater than 1, we have like 2, 3, 4, any number greater than 1 up to what? 10. For example, we have 628,000, which is equal to 6.28 times 10 to the power of 5. We are going to make our answer into what? Standard form. You know what is standard form, right? In your previous classes. So we are going to start this counting from what? 6.2. We are going to start the counting from here. 6.2 62800, which is equal to 6.28 times 10 to the power of 5. This 5 is coming out from here, 28000. How many digits are there? There are 5. Then you should put this 6.28 times 10 to the power of 5. Log of 62800 is the same thing as 5.7980 when you press your calculator. where 5 is integer and 7980 is the fraction, that is multiple. Is that clear? If a number is in its standard form, its power is its integer, that is the integer of its logarithm. That is the integer of its logarithm. Example, log 7853 has integer 3 because 7853 is equal to 7.853 times 10 to the power of 0. As I told you earlier, you are going to start the counting from here. You should omit this 7. Then you should start counting from 853. You see, this 853 is our what? Integer power of 3. Is that clear? So let us move to next example. It says use tables means logarithm to find the complete logarithm of the following numbers. Instead of to use for figure table, you can use this calculator. Just use this one. These are the examples. A 80030, B 8, C 135.80. Solution: log 80030 is equal to 4.9033. Also log 8 is the same thing as this. Log of 13580 is the same thing as this. Then example 2, you should do it by yourself. It's the same thing as example 1. You can use the logarithm to complete this. You get it? So we are going to look into multiplication and division of numbers greater than 1 using logarithm. To multiply and divide numbers using logarithm, first express the number as logarithm and then apply the addition and subtraction laws of indices to the logarithm. You know what is laws of indices called? So add the logarithm when multiplying and subtracting, when dividing. When you add the logarithm, then you have to multiply and subtract when dividing. Is that clear? Example, you say evaluate using logarithm. Number 1, 4 627 times 2 9.3. Number 2, 8198 divided by 3.905. Number 3, 48.63 times 10 times 8.53 divided by 15.39. These are the solutions. The solution of number 1 is this. This is the number 1. 4627 times 2 times 2 9.3. These are the numbers and this is the logarithm. Log of this 4627, it will give you this 36653 times, then you should put your times here. Log of this 29.3 to give you this. Do you get it? Then you should add this one. When you add this one, it will give you this 5.1322. Then the antilog, you know what is antilog? It's 135600. When you cross this one, it will give you this 4627 times 29.3 to give you this. Is that clear? Then you should move to the next example. It's the same thing as example number 1. Do you get it? So I think from this, let us stop here. So we meet to the next class. If you have a question or problem under this, you should contact me later. Thank you.